What's up, people? I'm back. Alright. So up to this point, we've been talking about these proportional tables. And today, we're going to take them tables and we're going to turn them into some graphs. So we got some important things to speak on here about what a graph is supposed to look like here on the proportional graph. Okay? So for them to be proportional, they have to have these qualities. I'll let the music run there a little bit in the background. I kind of like this. This right here is a bop from the lady that had the most top 10 hits in the 80s. So there's a little hint for you for later. Okay, this lady had the most top 10 hits in the 80s. So qualities that a proportional graph must have. Alright, so we got a couple qualities. We're going to do an A, B for sure, and then we might do another one here in a minute. Okay, so number one, it must be a straight line. Alright, it must be a straight line, okay? Otherwise, the term you would want to use is that it must be linear, okay? So it can't be all janky and all crooked and have curves and whatnot, okay? It's got to be a straight line. Alright, second important thing is must touch the origin. Alright, so when you draw it, it must come down to the origin. Now what point is the origin? Well, that of course would be 0, 0. Well, we may add something else to that in a minute, but let's start out with those two things and we'll see if there's anything else that we got to have come up with, okay? So this of course is, once you've got it worked out and you've got your table, okay, we're going to talk about the graph. So you might have this in your little packet there, okay, someone that says proportional relationships and graphs. So we're going to go ahead and take a look at this for just a minute. Alright, so this is about water usage. Okay, back before 94, shower heads used 5 gallons of water per minute. Okay, so in 1 minute it used 5 gallons. And
in 3 minutes it would be 15 gallons. Now, to find out how many minutes, of course, you'd have to do that divided by 5. And 35 divided by 5 would be 7 minutes. Here, of course, you'd do 10 times 5 because that's your COP. 10 times 5, of course, is 50. Alright, so of course, this would be, it says, is this a proportional relationship? You would say yes, because it has a COP of 5. Okay? And if you had to write an equation for that, okay, of course that would be y equals 5x. It didn't ask for that, but I'm just throwing that in there. Alright, now plot the data from the table. So we're going to come down here and we're going to plot the little data. I think I'll do it in blue. So 1, 5, 2, 10, 3, 15, 7, 35, and then 10, 50. Okay, if you hook all those together, okay, I'm just going to start here. Of course, it would keep going. Alright, so let's talk about some things. So if we go back to our questions we had here, is that a straight line and does it touch, oh I'm sorry, I can't see that. Is it a straight line and does it touch the origin? Alright, so let's look. Is that a straight line? Yes. Does it touch the origin? Yes. So this is showing you what a graph of a proportional relationship must look like. Okay, it's linear and it does touch 0, 0, which is the origin. Okay, so now it says if you continued the table to include 23 minutes, would the point 23, 125 be on this graph? Alright, so that means if we're going to go 23 minutes, of course it'd be way out here somewhere. So right here we're just going to do 23 times 5. 5 times 3 is 15. And then 5 times 2, of course, is 10, plus 1 is 11. So it actually would be 23, 115 would be on there. So would that point be on the graph? That one is a no, okay? It would have to be 23, 115. That would be on the graph. So for that one, the 125 is wrong. It's supposed to be 115. All right? So, if we reflect on this, does it make sense it's going to go through the origin? Well, of course, if you're not using any water, okay, if you don't start it. So at 0 time, there's going to be 0 water use. So if you're not using it, there's no water use. So yes, that makes sense. Another shower head uses less water per minute. How would this graph compare to the one you plotted? So if it was using less water, okay, if it was using less water, it would be, of course, down in this area, okay, because it'd be using less than 5 per minute. All right, let's flip it over and take a look at another one real quick. Okay, so if you look right here, so it says, in addition to using the table to determine if a relationship is proportional, you can also use a graph. A relationship is a proportional relationship if its graph is a straight line, there's A, through the origin, B. So if you look at that, that's a straight line through the origin. All right, so let's take a look at this one and see if this one's going to work. All right, it says the internet cafe charges a one-time $5 service fee and then $2 for every hour of use. Is this relationship a proportional relationship? So for the first hour, they charge you $5 service fee and then $2 for every hour of use. So that's 7. All right, for the next hour, okay, they're not going to charge, since that's a one-time $5 service fee, they're not going to charge you $5 again, they're just going to charge you $2 more dollars. So that would, of course, be $2 more dollars, which would be 9. All right, at 5 hours, that would be the $5 service fee plus $2 for the 5 hours, so that would be 10. And I'm sorry, that would be 8 for the next 4 hours. So 5 for the first hour, 8 for the next 4, so that would be 13. All right, for 17, that would be 2 more hours after that, so that would be 7. And then 8, that would be $2 more after that one, so that would be 19. All right, so if we plot all that, we've got 1, 7, which would be somewhere in there, 2, 9, 5, 13, 7, 17, and 8, 19. All right, so just kind of put them halfway in between there. So if you hook all those together, okay. All right, so let's check our 2 things. Again, our 2 things are, it's got to be a straight line, which means it's got to be linear. It's got to touch the origin, which means it's got to hit 0, 0. So is that linear? Pretty much, that would be a yes. Does it touch the origin? That is a no. So the graph of the data is a linear equation, but the line does not, okay, it does not go through the origin, so the relationship is not proportional. Okay, so easy enough. So if you look at this one, it's straight, it's linear, it goes to the origin. This one is straight, which is good, that's part A. But then part B, it does not go through the origin, so it's got to do both. So let's take a look at this one about fingernail growth real quick. This will be our last one, okay? So first of all, is this linear? Yes. Does it hit the origin? Yes. So this is showing a proportional relationship, okay? This is proportional. So yes. Now, what does the 0.39 represent? Okay, so if you come over 3, that's 3 years. 9 is there. So that means in 3 years, your fingernails are going to grow 9 centimeters. In 3 years, your nails will grow 9 centimeters. Okay? Because this is about fingernail growth. Okay? 3 years, 9 centimeters. So how do you get the constant of proportionality? Well, you got to do the y divided by the x. So what's 9 divided by 3? 9 divided by 3 is 3. Right? So that means every year your fingernails are basically going to grow 3 centimeters. What kind of equation could you write for that? That would be y equals 3x. Alright? 0, 0 means, of course, no time passes, your fingernail don't grow. So that means before you're born, right? Before you're ever even conceived. You don't have any fingernails because you hadn't been made yet. Okay? No time passes. So no fingernail growth. Alright. What is the rate at which a fingernail grows? Well, we got that up there, right? We said every year it would grow 3 centimeters. 3 centimeters per year. That's the unit rate. How does this relate to the constant of proportionality? Well, that's the same, right? The unit rate and the COP. COP and unit rate are exactly the same. They are both 3 centimeters per year. Alright, remember the COP and unit rate are the same thing. Alright, so you're going to have some practice and some tables here, and you're going to have some graphs to do. Just remember that the main 2 things on the graph are, it's got to be a straight line, and it's got to go to the origin, okay? Must be a straight line. Must go to and touch the origin. Those are the 2 big things for a proportional graph. If they do those 2 things, it's a yes. If they don't do those 2 things, it is a no. Like this one over here. Okay? Did not touch the origin, it was a no. Okay, so I'm trying to keep it short and sweet, people. If you know who this person is and what this song is, okay, please let me know. You can email me and your question as well. So this is a 80s, big 80s lady, okay, with this song. That's the only hint I'll give you. So until next time, people, keep them lines straight and make them touch 0, 0. So let them hit the origin. Then it's going to be a yes.
If they're straight and they touch the origin, it's a yes. If they're not straight and they're all crooked, like a dog's hind leg, then it's going to be a no. If they don't hit the origin, it's going to be a no. So as they would say in the Francais, a ciao for now, baby. Adios.